Good day, guys. Welcome to our class, Calculus 2, and our topic for today is about exponential functions. So, in exponential functions, there are two basic formulas that we usually use. The first one is e raised to the power of u du, which gives you eu plus c. And the other one is integral of au du is equals to au over ln of a plus c, where a is greater than 0. So where a is a constant value or a number. So if you can see here, we have some examples for our a and for our b, and we have some more examples. Okay. So let's try solving the first example. Okay. Exponential function, the very basic, e raised to the power of 2x. We know that e raised to the power of u, where u is a variable, it is automatically equal to, or the integral of that is equal to e raised to the power of u. But in this case, because your u is not only x but 2x, then you need to let value u will be equal to 2x. After that, you need to derive 2x, which gives you 2 dx. And we get our dx, so that we have an easy here means to integrate. So you have dx, you have du, transpose the 2 to the other side, you have du over 2. So from here, we need to substitute these values to your given. So we have our integral e raised to the power of 2x. 2x is what? 2x is our u. Then, sorry, forgot to put dx here. And our dx is du over 2. Okay. So from there, we will move the constant values outside your integral sign. So therefore, what remains inside your integral sign is your eu raised to the power times du. And we know that integral of eu du is equal to eu plus c. So you have integral of eu du is eu then plus c. But need to substitute because our output here have variable u, but our given are x. So we need to substitute your u, the value of u, to this answer. So you have 1/2 e raised to the power of 2x, that is the value of u, plus c. Okay. So actually, guys, there is a much easier way. We don't need to solve this. So this is the fastest way to know the integral of this. We just, if you have values beside a variable, simply make a quotient 1 over, or reciprocal of this, 1 over 2, then copy. If you can see, reciprocal of 2 is 1 over 2, 1 over 2, e raised to the power of 2x. In the derivative, when you derive this one, you need to multiply the power, the value, then copy. So that's how you do it. But in the integral, that is 1 over the value. Okay? 1, always have 1 over that value, then copy the given. That's the most easiest one. So from here, I've just show you the steps how it becomes like that. Because others, when you go to advanced math, Laplace, etc., you are, especially when we talk and also for our next topics, the integration by parts. So we could have something like this na mga need to integrate or derive. So this is the example of the first formula. The second basic formula states that a constant a raised to the power of a variable times du du will give you a result of a constant raised to the power of u over a logarithmic of that value plus c, where a is a constant value, a is a greater than 0. So let's try. So from here, let's reform this one, rearrange this one to have a result of 3. When we put this denominator to numerator, the power becomes negative. Okay? Then we have x. Okay? So because we raise this one up, so the power have a negative sign. Now, next, what will we do? We need to let value of our x, we left that one. Let u be equal to negative 2x and our du will be equal to negative 2 dx, where our dx will be equal to du over negative 2. So just simply transposing those values beside your dx to the other side so that you could go get your dx. Okay. So from there, need to substitute these values to the given. If you could see from the first topics, we've used this with letting some values, our process is always the same. With regards to exponential, trigonometric, logarithmic, so we let some values and substitute it back. So it's just simple as that. The process is the same and it is much clearer because you will end up with the exact form of the identities. So now let's continue. So we have to substitute. So this is already our new form. So you have our 3. This is our u. Okay? And our dx is du over negative 2. We cannot move the 3 outside because you have a variable there. So therefore, you will have negative 1/2. Okay? Negative 1/2. And then, you have 3u du. And we know that AU du, where your A is a value, your A is a number or a value, is equal to AU over ln A. So when you integrate this one, this is the equivalent. So therefore, you have negative 1/2. What is our answer? Multiplied by 3u over ln of what is our A? The A is our 3 plus c. Then we substitute the value of u. We have 1/2 3 raised to the power of negative 2x over ln 3 plus c. We could have this one or we could put this one below. So like what we did here, we could put this one below. So we have negative 1, 2 times 3 negative, it becomes positive already, 2x, then ln 3 plus c. So you could have any of this answer for this given problem. So if you could see, this still considered as one of the formula of exponential function, which is the letter b. But the most common exponential formula that is used is this e raised to the power of u du is equals to e plus c. So if you have a value, have a constant value, then you need to first to derive those value. Okay, so let's try more examples. Okay, so we'll just delete those spaces if makuha man ta. Okay, so let's try another example. So from here we have a given of sine 2x e raised to the power of cosine 2x dx. So it is combination of exponential plus trigonometric na mga identities. Okay. So, but in this case, this is very, very basic. We don't need to use mga methods and techniques like integration by parts, uh, trigonometric substitution, rational fractions, and etc. So, this is very basic. So, let's try to solve it. So, in this case, we need to let your u be equal to what? What will be our u? Our target here is to cancel a term. Cancel a term. Okay. So, what will we put for our u? Is it sine 2x or cosine 2x? So, the answer is the cosine 2x. Why? Because when we put our sine, we derive our sine, it becomes cosine, right? Then, if you have cosine here, you can still cancel your cosine from a power of your exponential. But if u will be cosine, when you derive this one, you could have a sine and then you will have a result that this value could be cancelled from the result beside your dx. Okay, let me show you how it works. So our u will, as I told you, is cosine 2x. And our du is equivalent to, what is the derivative of cosine 2x? Remember your differential calculus? Cosine 2x is, you have your 2 here. Derivative of cosine is positive or negative sign. That is negative sign. So you have negative 2 sine 2x. Correct? Because the derivative of sine is positive cosine, so the derivative of cosine is negative sine. Okay. And I forgot the dx. And our dx will be equal to du over negative 2 sine 2x. If you could see, our steps is redundant. It's repeating for you to have an easier means or a habit for you to recall the steps. The steps is very important. Even the form, if even the given will be different, if you know the process, you could still solve it. Okay? So, let's continue. So, our given, let's substitute these values to your given. So, our given, so later we'll put it there na lang, so that we can fit it. So, from here, we have, okay, substitute or given sine 2x. Don't have sine 2x there. Then we have e raised to the power cosine 2x is our u. Very good. Multiplied by your dx. What is our dx? That is negative du over, or put negative here, 2 sine 2x. If you could see, sine 2x and here 2 sine 2x, you could cancel this sine 2x and this sine 2x. Okay? So from there, what remains is we have a constant negative 1 over negative 2. We'll move that one outside your integral sign. What remains is your eu and your du. And your negative will be outside. If you could see our means of solving it, we always end up with the form of our identity or our basic formulas. Sorry. So this is the benefit of having these things and getting your dx, because you always end up with these identities, and it will make you memorize and understand those identities. Okay? So from there, you'll have negative 1/2, and we know that the integral of EU is equivalent to EU plus C. And we have negative 1/2 e raised to the power of, what is our u? Cosine 2x. Cos 2x plus c. Okay, 1/2 e raised to the power of cosine 2x. Okay, so can we look at it? Okay, I'll be here. Look at it first. Before we continue with the other problems. Okay? So let me erase this one so that we have space to solve that problem. Let me erase this one. Okay? So while you look at that problem, let me erase this one. So we have number 2, this problem. We have integral e raised to the power of x times square root of 1 minus e raised to the power of x in x. So the process of this, we are still on the basic concept and formulas. We are not yet on those techniques. We are not yet on the technique. So the very rule is to have something to be cancelled. Okay? So okay. So let's try to continue. So we have this value, this given equation, we try to solve. From here, we need again to let the value of u. What will be your u? Is it e raised to the power of x or 1 minus e raised to the power of x? Because our target is to have a value that could cancel one of those, or term that could cancel one of this, e raised to the power of x or the other one. So basically the answer will be 1 minus e raised to the power of x, because when we derive this one, that is still e raised to the power of x. So du will have derivative of 1, that is 0. When you derive a constant, that is 0. Okay? So you have negative e raised to the power of x. We know that derivative of e raised to the power of x is e raised to the power of x dx. Okay? So derivative of e raised to the power of x is still e raised to the power of x, the same as the integral. So negative here because you have a 1 minus. Okay? So your dx will be, transposing the negative e raised to the power of x to the other side, you have e raised to the power of x. Then after that, we need to substitute it to the given. So we have here e raised to the power of x, then is square root of what is 1 minus e to the power of x, that is our u, Then what is our dx? Du over negative e raised to the power of x. And we could see this is denominator, this becomes the numerator. When you multiply du to here, that is numerator. So therefore, we could cancel this one, but our negative still remains. Okay, let me erase this one so that we can use the space. Okay, so let's continue this one here. So we have our negative sign move outside. It's just like negative 1 integral of square root of u du. Okay? Square root of u du. So, from there, actually, ano rin siya? So, this becomes a power rule. So, we have here, u raised to the power of 1/2 because square root of u is u raised to the power of 1/2 du. So, this becomes power rule. So you have negative. When you integrate that one, you have u raised to the power of 1/2 plus 1. This power rule or the integration of powers, identity number 4, you have over the new power plus 1 plus c. So therefore, we have negative u to the power of 3/2 because you have 1/2 plus 1. 1 is just, if you could see the denominator of this, that is 2. So we could, so that we could have the same denominator, we could add this one easier. Let's make the 1 as 2 over 2 because 2 over 2 is just equal to 1. So that we could easily add that 1, we copy the denominator and put the same numerator so that it still be equal to 1. So it is much easier to get it. Or you could use your calculator or the basic algebra. Okay? So you have 3/2 plus c. And we are not yet done for a reason that we still have over u. So let's just put the 3/2 to 2 over 3 because when I transfer this one here, you have negative happy 2 over 3 over u 3/2 plus c. So negative 2/3. What is our u? Our u is, where's our u? 1 minus e raised to the power of x. That is 1 minus e raised to the power of x 3/2 plus c. Okay? So, we have that answer. Okay? So, for more examples for this topic, this is the very basic steps of doing exponential function. For more examples, please look at our class library. There are many books there. Try to solve, but the process will always be the same. If you follow this process, it will always be the same, except if the problem needs to have those techniques or integral techniques, integration techniques. So, but now we are still on the basic exponential functions, so you can have this one. So for the more advanced topics for this, we'll have to use more different integration techniques, which will be on our next topics. So I think this will be all for our discussion exponential functions. And I will see you next session for our next topic, which is inverse trigonometric function. Okay, good day and God bless.